Alright, hey guys, this is going to be our video for section 7.4 in your book, and you will actually be needing your book for this because I'm going to have you writing down some definitions from your book as we go. So if you want to go ahead and open your book up to page 495, and while you're there, go ahead and copy theorem 7-4-1 into your notes. This is our triangle proportionality theorem. So basically what it's saying is that if a line parallel to a side of a triangle intersects the other two sides, then it divides those sides proportionally. So go ahead and get that theorem down in your notes, pause this video until you do, and then come on back and we are going to prove this theorem and do an example. Alright, for this next section you're going to need a ruler and a protractor, so if you do not have those, go ahead and grab them. If you are at home and you don't have a ruler, any kind of straight edge will work, a piece of thick cardstock or something like that. If you do not have a protractor, then you'll probably want to either come and grab one from class tomorrow and work on it on your own, or if you can find another way to use it, find one online or something like that, that would work as well. So what you need to do is you need to use your straight edge to draw a triangle ABC on your paper. So go ahead and do that. Draw a triangle ABC. Okay, once you've drawn triangle ABC, you need to draw point E on side AC. Doesn't matter where. I'll let you choose where you want to put it. But you're going to draw point E on side AC. So that's point E. All right, once you've done that, you're going to construct an angle at E that is congruent with angle C. So we have this angle here, and you're going to draw an angle up here that is congruent to angle C. So this is where you need to use your protractor. Hold that protractor up to angle C and see what measure it is, and hold it up to B and draw the other side of that angle. Okay? So go ahead and extend that side of your angle all the way out to the other side of the triangle. And there we have a line. We're going to name the other side of this line, at the point that it intersects, we're going to name that F. So now you have line EF. Now we can say that line EF is parallel to line CB because of these two angles that we drew earlier. Why is that? Why can knowing these two angles tell us that lines EF and CB are parallel? See if you can remember that. Alright, hopefully you remembered that angle E and angle C are corresponding, and if our corresponding angles are congruent, then our lines are parallel. Alright, great job. Let's try an example. Alright, we got a triangle here. We have triangle ABC, and it's being intersected by line XY. Now this problem already tells us that XY and AB are parallel, so that means that we should know that XY divides sides AC and BC into proportional pieces. Okay, so we're going to have to set up a proportion in order to solve this. Now let's just come over to the side. So we know that side BY is proportional to YC, and AX is proportional to XC, based on that theorem that we just wrote down. Now let's put in our numbers. BY is 9, YC is 4, and then AX is 10, and XC is X. We don't know what that is. That's what we're trying to solve for. Okay, so remember how we solve our proportions. We're going to cross multiply, and we get 9x equals 40. Then to solve for x, we would divide both sides by 9. And to get your answer, you can either leave that as 40 over 9, or you could see that it's 4.4 repeating. So there you go. That's how you would use our triangle proportionality theorem. Alright, next we have another theorem for you. This is the converse. So remember, converse means we're switching our hypothesis and conclusion. So it's basically what we just said in the triangle proportionality theorem, but we're switching our hypothesis and conclusion. So go ahead and write that down. It's on page 496. Okay? Hopefully you got that theorem written down. The theorem says that if a line divides the two sides of a triangle proportionally, then it is parallel to the third side. So basically, if we can prove that the two sides are proportional, we can prove that that line is parallel to another one. So let's look at this example. It wants us to verify that MN is parallel to KL. Now we're going to do that by showing that our proportions of our sides are equal. So let's set that up. I have 42 over 21, the proportion set up with this side, equals 30 over 15. Now if this proportion is true, then I can say that MN is parallel to KL. So let's see if we can check it. 42 over 21 reduces to 2. 30 over 15 reduces to 2. That's a true statement, so we can in fact say MN is parallel to KL. All right, so that's it for that one. That's the whole thing that we use it for. Now there is one more piece to it, and that's what I have you copy on the next slide. So underneath the theorem that we just copied, there's a corollary. That just means there's like an add-on. So go ahead and get that on page 496. We've been having two parallel lines in the triangle, but in this case it's going to tell us what happens if there's three or more parallel lines. Okay, so go ahead and write down that corollary in your notes. All right, and then while you're in your book, go ahead and write down this last theorem. This is theorem 7-4-4. It talks about an angle bisector. So I know some of you had a question about angle bisectors when we were doing triangle congruence, and saying that if a segment bisects an angle, then it automatically bisects the other side, and that's not true. Okay? So what happens is if an angle bisector of a triangle divides the opposite side, it divides it into two segments whose lengths are proportional to the lengths of the other two sides. All right, so go ahead and get that theorem in your notes and come back for our last example. Okay, so we're going to put this to the test, our triangle angle bisector theorem. So here's a triangle. We have triangle RST, and we're looking at SV bisects angle S, or angle RST. We can see that because it has the two congruency marks. So then we can say that RV and VT are proportional to RS and TS. So then we need to figure out what that proportion is. So we have 10 over 14 equals, now let's set that up. So x plus 2 in the same triangle as 10, so I'm going to do x plus 2 over 2x plus 1. And then remember how we are going to solve this. So 10 times 2x plus 1 equals 14 times x plus 2. Then you have to distribute. So I get 20x plus 10 equals 14x plus 28. Now I can subtract 14x from both sides. I get 6x plus 10 equals 28. I'm going to have to move up here to get a little bit more room. If I subtract 10 from both sides, I get 6x equals 18. Divide by 6, and x equals 3. Can I stop there? I hope you are yelling at your computer saying, no, don't stop there, because the problem asked me to solve for RV and VT, which means I need to put this value of x back into this problem. So x plus 2, 3 plus 2 is 5. 2x plus 1, 2 times 3 is 6, plus 1 is 7. So now I've completely solved the problem. And that's it for this chapter. You guys can go ahead and start working on your homework. If you didn't catch anything in this video, please go back and watch it so you can make sure you get everything. All right, have a good night.